Alright.
The point that the lines cross.
Yes. So today we're going to be starting 4-2. We're going to be continuing on chapter 4. Now, chapter 4, it's actually all the same problem. It's all solving systems of equations. But what I'm doing is I'm showing you all the different ways to solve them. So we wrote the systems from the word problems and we plugged them in the calculator into LinSolve. Right, that was the first way. Today we're going to be doing graphing and tables. All right, and then later on we're going to be doing some other ways. But just so you know, it's still all the same problem. It's just another way of solving it. Right, so still all the same problem. So on these notes, we're going to start by graphing it first. And it says the solution to a system of equations is the point that the lines, and Quaterion said cross or intersect. I'm going to use the word intersect because it's fancier. But yes, it's where they cross or intersect.
Intercept or intersect?
Intersect.
Oh no.
Intersect.
I put cross.
Cross is fine.
I love you too, but you be tripping.
All right. These first two examples, I'm going to do it with the calculator. I'm going to show you how to graph them with the calculator. All right. And so if you want to get a calculator, you can. If you just want to watch and follow along, that's fine too. So first of all, notice that my problem is not in y equals. All right, it says x plus 2y equals 4. And this is y equals. That's what f of x means. So they're not in the same format. Right. So what you have to do is, and I think there's another way you could do this, but delete the equal sign and go down to relation. And then everything is blank. And then you can type anything you want. X plus 2y equals 4. Hit enter. And then some people, I think, in the other class, hold on.
Isn't it tab?
No, they showed me another way. Was it menu 3-2? Yeah, menu 3-2 will also give you the relation. So, yeah. So I'm guessing that's how you were taught, which is why. But anyways, you still do the same thing. X plus 2y equals 4. Hit enter, and then yes, press tab to get the box back so you can put the other equation down. What do you need?
Can we write on the side of the stamp on?
Yeah, you can write on the test too.
We can write on the test too.
Because I don't need them anymore.
Okay.
2x minus y equals 6. And there's my other line. So your graph, oh my goodness, what did I just do?
I was going to say bless you because I thought you sneezed.
Okay. Your graph doesn't need to be exact. I just want you to know that this point right here is your answer. The point that they cross, this is your answer.
This is so accurate. I love it.
It doesn't have to be accurate. Just kind of sketch your two lines. And the reason why you're just sketching them is so if you look back at these notes, you know that you're finding the intersection point. That's what you're finding. This point right here.
Like that.
So in your calculator, menu, analyze your graph, intersection. Menu, analyze, intersection. And you have the dotted line here. And you are going to press it, and then you are going to highlight your intersection point. Press it again, and your little black dot points at the intersection, and your point is 3.2, 0.4.
Can you solve this by hand?
Yep, we're going to do that tomorrow or the next day.
If you because with this one, you can easily use
That was the only thing I learned from this program last year.
Right.
Okay, so
this one, thank God.
who wants to come do the second one?
Faith, don't be volunteering to do that.
Come on, Faith, you can do it.
You are
I have
volunteering.
faith in
Talk it out. Teach the class.
Faith doesn't know what she's doing. And we're recording this. Hi guys,
Yes,
welcome
we are
back to my
recording.
channel.
Make sure you click the bell.
Okay, so you're gonna go back, go to relation, and it's y. Oh, these nails. Minus 2x equals 1. Right? And then you enter it. Then you click tab. Oh no! We're gonna click that button. Click tab. Go to the next one. It's gonna be negative x. I'm getting anxious. Minus y equals 2. Ta-da! And then you're gonna draw it. Whoosh.
This name's a lion.
That was so bad. That's not what I was. And then that's your answer. Do I have to label answer and stuff? Okay, that's your little cross section is your answer. Then you go to menu, analyze graph, intersection, and you highlight the intersection. Whoops. And the answer should be, what the heck and heck? Oh, okay. The answer is -1, -1. That's not how you say it, but yes.
Good job.
Oh man, my graph was close. I got -2. So
Next time she asks for volunteer, Corterion, guess who's going up there?
you.
Good job, Faith. All right, so any questions on graphing using the calculator? All right, cool. Go down here to the table. All right, so solving the systems of equations using the table. What this is two functions, like two tables, and they squish it together as one table. So like this is your first table, and then this was your second table. See how they use the x value twice? All right, so I'm going to check the points, and we're looking for a point that is the same in both tables. Because if you have a point that's the same in both tables, that means that is where your your intersection is. So in the first function, I have the point 0, 6. I have the point 1, -1. And I have the point 4, 3. For your second graph, what's one of my points?
0, -6.
0, -6. What's another one? 1, 1. Good. And what's the last one?
4, 3.
Good. So looking at these points, which one is the same?
4, 3.
4, 3. So your answer is 4, 3.
Are you roasting her?
No, I'm not.
All right, number 4 says, what is the disadvantage of solving systems using a table?
Inaccuracy.
Be more specific.
Inaccuracy.
That's the only answer that popped up in my head. So.
It's okay. So if you're given a table, you're only given a piece of the graph. So the table might not give you the solution. That doesn't mean that there is no solution. It just doesn't give it to you. So you have to either do more work or say there's not enough information. All right? Does that make sense?
Yeah.
Like, it might not give you the specific solution, but there actually is, like on this one with a decimal. Normally decimals are not in the table when you look at the table in your graph. And so even though it has a solution, it might not automatically appear on the table.
So unless one of the answers is not enough information, we have to work it out.
I probably won't give you one like that, but that's it's one of the disadvantages of tables.
I just put always. I'm pretty sure I spelled that.
All right, so the solution might not be given in the table.
Not enough info.
But it might exist still. So we just don't know. So it's just not enough information when they gives you a table because it just gives you a little piece of the graph. So that's why tables normally aren't used that often. That's probably the least common way you'll see solving systems. But I mean, I guess technically it is a way, so that's why we gotta talk about it. All right, any questions so far? Cool, almost done. Flip it over. Almost. All right, on number 5, how many solutions does that one have? No solution. Yeah, no solution.
Jasmine, what? No solution.
Why does it have no solutions?
They don't cross.
Because they don't cross and they're parallel. So, oops. So,
Is that how we all people?
parallel lines. Thinking about the equations of parallel lines.
They have the same slope.
Very good, Quaterion. Same slope. All right, and if you are going to have no solution, your y-intercepts need to be different. Oh my gosh, I keep messing up. All right, so parallel lines means you're going to have the same slope, but I want different y-intercepts. All right, why do I want different y-intercepts?
Well, they're parallel.
Right, well, what would happen if they're the same?
They would be on each other like that.
Right. If you have the same y-intercept, they're going to be on top of each other like number 6. How many solutions does number 6 have?
All numbers.
All of them. So in math, I'm going to say infinity number of solutions.
A wonderful memory.
Because it is the same line. So the slope is the same. And the y-intercept is the same. Everything is the same. Slope and y-intercept. Alright, so those are kind of your two cases if you have the same slope. It's either going to be a no solution or infinity. And depending on where your y-intercept is. No solution, they're never going to cross. Infinity means they're touching at a lot of different spots. Okay, and then probably the most common kind, number 7, where you just have how many solutions? 1, and specifically, where is the solution at? 1, -2. Right here. And you are going to get one solution if you have different slopes. Right? Different slopes, and you will have one solution. Y-intercept doesn't matter. As long as you have different slopes, you're going to get a solution. One solution. Alright, last one, number 8. If I wanted to solve this without a calculator. Okay, without a calculator. Solve by graphing without a calculator. By graphing. So I want to graph this without a calculator. My problem is these are not in y equals. So I'm going to get it in y equals. So I'm going to do the bottom one first. 2x plus y equals 2. So if I want to get the y by itself, Andrew, what do I do first? Subtract what? 2x. Yes. Subtract 2x from both sides. Evelyn, can I combine 2 and negative 2x? No, because? Right, because they're not the same. They're not like terms. So I just write negative 2x plus 2. And Emery, where is my y-intercept? Positive 2. Very good. Positive 2. And Christian, what's my slope? Negative 2 over 1. So down 2 over 1. Down 2 over 1. Oh, that was bad. That's okay. Finished? Sweet. Sorry I drew my line so crooked. I didn't hit any of the points. I don't know what I was doing. Okay, so we're going to do the first one now. X plus 2y equals 4. Alright, Kanaya, what's the first thing I'm going to do? On this one.
Subtract x.
Yeah, subtract x. Subtract x. Caitlin, can I combine 4 and negative x? No, because they're not like terms. So minus x plus 4. Leslie, what's the next thing?
Divide by 2.
Divide by 2. Divide by 2. Divide by 2.
Do you have to divide?
Yes, you need to divide everything by 2. So, who am I calling? Asalia. What number's in front of the x?
1.
Shh, Asalia. 1. So, my slope is negative 1 over 2. X. And Josh. Josh,
Is it okay if I rotate?
look alive. 4 divided by 2.
No, it's not okay.
What's, huh? What's 4 divided by 2?
Josh, did you
4 divided by 2.
Yes. 2. Good. Okay, and who haven't I called on yet? Briseda.
The light.
Raimundo, you're next. Briseda, where's my y-intercept? 2, very good. And Raimundo, what's my slope?
-1.5.
Good, negative 1/2. So I'm going to go down 1 over 2. So, Lily, what is my solution?
Nice name.
0, 2. Very good.